Welcome back to another video. This is Enhanced Impact and I'm Felicia. Today we're going to cover AI agents. Today we're talking about AI and AI agents. And in this video we're going to break down what AI agents are, how they work, and why they're becoming such an important part of modern intelligence systems. By the end, you'll understand how agents perceive information, reason about it, and take meaningful action. Let's start with a simple definition. An AI agent is a system that can perceive, reason, and act toward a goal. It begins by perceiving, just taking in information from the environment. That could be text, data, documents, or even the output of a tool. Next, it reasons, deciding what to do based on context, memory, and the tool it has available. And finally, it acts, executing real tasks like calling APIs, querying databases, or generating reports. This perceive, reason, act cycle is the foundation of every AI agent. Now, let's look at the agent loop in more detail. First, the agent perceives an input. This might be a question, a document, a web page, or even a live data feed. Second, it reasons about the best next step. Should it search the web, retrieve memory, call a tool, or ask the user for clarification? And third, it acts, running code, fetching data, writing a summary, or updating memory. This loop continues until the agent completes the task. It's dynamic, adaptive, and goal-driven. So what's the difference between a chatbot and an AI agent? Here's the key distinction. A chatbot generates text. That's it. It doesn't remember past interactions. It doesn't take actions, and it doesn't plan. An AI agent, on the other hand, can take actions, store and recall memory, and work through multi-step workflows. It's goal-driven, not just reactive. The simplest way to think about it is this. Agents equal chatbots plus tools plus memory plus decision making. AI agents come in many forms. Here are 7 broad categories. Reactive agents, which are simple question and answer systems. Memory augmented agents like RAG and research agents. Tool using agents, which can browse the web or run code. Planning agents, capable of multi-step reasoning, often built with frameworks like LangGraph. Autonomous agents, which monitor, schedule, or operate continuously. Robotics agents, interacting with the physical world. And multi-agent systems, where teams of agents collaborate to solve complex problems. These categories help us understand the wide range of agent capabilities. So, do all agents need a vector database? Not all agents need a vector database. Vector databases are only required when an agent needs memory, retrieval, or knowledge grounding. They enable semantic search, memory recall, deduplication, and context-aware reasoning. Agents like research assistants, knowledge bots, and RAG pipelines rely heavily on vector databases. But agents that simply automate tasks like web automation, code execution, or rule-based planners don't need one. It all depends on whether the agent needs to remember and reuse information. Here's a real-world example of an AI agent. A research agent built with LangGraph and ChromaDB. Before we actually take a look at it in action, let's go over a couple things about this agent, how it actually works. First, it searches the web to gather the latest information. Second, it stores findings in a vector database and avoids duplicates. Third, it reasons over the information and summarizes it. Fourth, it brings the human into the loop for approval. And finally, it generates a polished, structured report. This is a complete agent workflow: perception, reasoning, action, and memory working together. Here is a demo of the AI research agent that I built to explore how agents can retrieve information, reason through a workflow, and store research knowledge over time. The agent combines a system that has Streamlit for the interface, Tavily for web research, LangGraph for state-based agent orchestration, OpenAI API for reasoning, and ChromaDB for vector memory. The agent retrieves information, generates responses, obtains feedback for, if I need to refine a search or accept a search with a human in the loop, and it stores the research insights for later retrieval. The interface is built with Streamlit so that it makes it easy to interact with the system through a simple web interface. When I submit a research question, the agent begins a workflow that coordinates several components. The first step is information retrieval. The agent uses Tavily, which is a search API designed specifically for AI agents to gather relevant information from a web search. The workflow itself is orchestrated using LangGraph, which lets the agent operate as a state machine, maintaining memory for context. Each state of the process, searching the web, processing results, generating an answer, and storing the knowledge, is represented as a node in the graph. This structure allows the agent to move through a multi-step reasoning workflow instead of relying on a single prompt. After retrieving the relevant information, the agent sends the context to the OpenAI API, which generates the final response based on the question and the retrieved sources. And again, with human in the loop, we can accept the research or request refinement. The research insights are stored in a Chroma vector database, which keeps embeddings of the information. This allows the agent to perform semantic retrieval later when similar questions are asked, and so it actually limits and actually avoids reusing the same search. So it kind of cuts down on repetitive searches over the same web addresses. So the system combines web search, stateful agent orchestration, language models, and vector memory to support a small research workflow. I hope that you enjoyed the demo. Thanks. Okay, let's wrap up with the key takeaways. AI agents perceive information from any source. They reason about what to do next. They act by executing real tasks. Memory augmented agents can learn and recall context, and multi agent systems can collaborate to solve complex workflows. In the next lesson, we'll build a small AI agent. And then we'll talk a little bit more in depth about vector databases, what they are, how to use them, how to query them, and we're going to be using LangGraph. Thanks for visiting today. If you like the video, click the thumbs up, subscribe. It's great motivation to keep me making these videos. And until next time, be well.